Hello everybody and welcome to lesson 6 of applications of integration. We are on exercise 21.2, page 464, and I've selected these two sums, question number 3 and 5 today. So let's begin with question number 3. The diagram shows part of the curves y is equal to 2x squared plus 3 and y is equal to 3x squared plus 2 intersecting at 1 and 5. So this is a point of intersection. Over here the x coordinate is 1 and the y is 5. Okay. Find the area of the shaded region. We need to find the area of this shaded region. So here you can see the x coordinate is 1. Okay, and y is 5. So from 0 to 1. Okay, you'll be calculating. So area of the shaded region, A is equal to sine of integration 0 to 1. Now we will be subtracting the lower curve from the upper curve. So first you write down the equation for the upper curve. At the upper curve you have y is 2x squared plus 3. So 2x squared plus 3 minus the lower curve is 3x squared plus 2. So whole thing we are integrating it with respect to x. So the shaded area is now equal to sine of integration 0 to 1. Let's open the bracket, 2x squared plus 3 minus 3x squared minus and plus is minus 2 dx. So the shaded area is now equal to 0 to 1. 2x squared minus 3x squared would give you minus x squared, and plus 3 minus 2 would give you plus 1. The whole thing dx. So the shaded area is now equal to, bring this minus sign out, 0 to 1, x squared dx plus sine of integration 0 to 1 dx. So area is equal to minus x squared, x will give you x cubed, so 1 over 3 x cubed 0 to 1 plus x 0 to 1. We have now integrated it. So a is equal to minus 1 over 3. Let's put the value of x, 1. 1 to the power 3 is 1, minus 0, plus 1 minus 0. So this will give you a is equal to minus 1 over 3 plus 1. So the shaded area is now equal to, taking LCM, 3 minus 1 plus 3. 3 minus 1 will give you 2 over 3. Okay, so 2 over 3 square unit will be answer. I hope it's clear to you all. So I've just solved the third question. Okay, and that's how you do it. So we'll now move on to the next question, question number 5. Excuse me. Question number 5. Says here the diagram shows part of the curve. The equation of this curve is x squared minus 4x plus 3, the upper one, and the lower curve is 6x minus 5 minus x squared. Here you can see that. It is intersecting at 2 points over here, point along x-axis, and over here. So this is point A, and here the point of intersection is B. So you have to calculate first the coordinates of A and B. That means what is x and y equal to at point A, and at point B what x and y is. Now as you can see, it is intersecting the x-axis. So at x-axis the point of intersection y will be 0. Okay. So we need to find the value of x. So let's put in this equation y is equals to x squared minus 4x plus 3. Let's take y is equals to 0 over here. So x squared minus 4x plus 3. So this would give us 3 1 3 minus 3x minus x plus 3. So we are factorizing it now. X minus 3 minus 1, x minus 3. So I've got two factors, x minus 3 and x minus 1 equals to 0. Now from here we can get the value of x. We have two values of x. Either x minus 3 equals to 0, so x is equals to 3, or x minus 1 equals to 0, so x is equals to 1. Now one of these values is correct and one is incorrect. They're both positive, okay, and they need to be positive because it is on the right hand side of the origin. But as you can see over here, it is less than 2. So you cannot take any values which is above 2. So 3 is incorrect and 1 is incorrect. So the x coordinate is 1. A, 1, and at y we already know is 0. So this is the answer. We just found out the coordinates at point A. Now, how about this coordinate at point B? We know that B over here lies, the x coordinate of B is 4. Okay? We need to know the y coordinates. So let's take the equation y is equals to 6x minus 5 minus x squared. We need to find y coordinate. The x coordinate is 4. So 6 times 4 minus 5 minus 4 the whole squared. So y is equals to 6 over 24 minus 5 minus 4 the whole squared is 16. So y is equals to 24 minus 16 minus 5 would give you minus 21. Yes. So y is equal to 3. So at point B, your x coordinate is 4, so y is 3. This is the answer. I hope it's clear to you all. Okay. Now we got the coordinates for A and B. Okay. Now moving on to the second part of this question, that is you have to find the area of the shaded region. Okay. So we need to find the area of the shaded region now. Right. So the B part of question number 5, the area of the shaded region. So the upper curve is the area of shaded region. The upper curve, as you can see, is x squared minus 4x plus 3. This is the equation for the upper curve. And we need to take from point from here to here. We know that over here we just calculated at point A, the x coordinate was 1. And point B it is 4. Okay. Now minus the lower curve. Now as you can see, the lower curve, this one, okay, this is below the x-axis. This is below the x-axis, and below the x-axis we take it as minus. So this has to be minus. So minus and minus will give you plus. Okay, we are subtracting the lower curve from the upper curve. So it has to be minus over here, but since this is below the x-axis, so we take this as minus. I could find the area of this upper curve separately and the lower curves separately and solve it. But since I bring it together, so directly I can write it down as plus. Minus and minus would give you plus. And the equation for the lower curve is 6x minus 5 minus x squared. The whole thing dx, because we are integrating it with respect to x. Right. So the area of the shaded region is now equal to integral 1 4 x squared minus 4x plus 3 plus 6x minus 5 minus x squared. dx plus x squared minus x squared will cancel. So the shaded area is now equal to 1, 4. 6 minus 4 would give you 2x, and 3 minus 5 will give you minus 2 dx. Now we can break it down. 1, 4, taking 2 outside, x dx minus 2, 1, 4 dx. So this would give us a is equal to 2 x squared over 2, 1, 4 minus 2 x 1, 2. So a is equal to, you can take this 2 outside, 2 over 2 x squared 1 to 4 minus 2 x 1 to 4. So it will cancel out. A is equal to x squared means 4, the whole square, 4 4 is 16, minus 1, the whole square will be 1, minus 2, 4 minus 1. So a is equal to 16 minus 1 will give you 15, minus 2 into 4 minus 1 will give you 3. So a is equal to 15 minus 3 is 6. Okay? You write the answer here. 15 minus 6 would give you 9. 9 square unit. This is the answer. I hope it's clear to you all. I've just completed question number 5, and the coordinates of A and B I already calculated, and now I got the area of the shaded region. Okay? Just remember this rule once again, that below the x-axis we'll have to take it as minus. Okay? And then since we are subtracting from the lower curve to the lower curve from the upper curve, so that's how minus and minus will be plus. That's how it goes plus sign. Right. So I hope it's clear to you all, and hope to see you in the next lesson. I'll be continuing with this exercise, and hopefully I'll be completing this chapter as well. Okay? Thank you. Till then, God bless you all, and take care.